Lesson 5, Exponents. So take a minute to pause and do this warm-up. So we're comparing fractions. There's a couple ways you can do this. One is to try and get them to have the same denominator. So right now we've got a 5 and a 3. So the same denominator, what number does 3 and 5 both go into? It'd be 15. So we can multiply this left one by 3 over 3. And this right one by 5 over 5. So we have 3/15 and 5/15. Now that they have the same denominator, we can compare those, and the right would be bigger than the left. The other way that we can do this is turn them both into decimals. 1/5 would be 0.20. 1/3 is 0.33 repeating, and that's bigger than the other one. 2/5 and 3/8. So 2/5. Let's see, 5 and 8 both go into 40. So we're multiplying both of the other side by 8 over 8, this side by 5 over 5. So we get 16 over 40 and then 15 over 40. So those are real close to each other, but the left would be bigger than the right because 16 is bigger than 15. Once you have these denominators the same, you're just looking at which of these numbers is bigger. For the last one, I know 4/9 is 0.4 repeating. 1/2 is 0.5, and 0.5 is bigger than 0.4. Go ahead and do these problems. So the first one, -6 times -5 is positive 30. 2 plus or minus -9. We've got two negatives in a row, so that means we need to change that to become a 2 plus 9. That's saying opposite of -9, which is plus 9. So that would be 11. 3 plus 5 would get you 8. This one can be tricky for students. So we've got these double negatives. So double negative becomes a positive. So we're adding, and -11 plus 11 would equal 0. And then the last one, we would get -5. We'll practice with 4 numbers. Go pause and see if we can find at least one way, and I'll show you a few solutions after. So here I see we could do 7 minus 1, which would be 6, times 8 divided by 2, which would be 4. And that would get you 24. It's 6 times 4. There may be other ones if you find, actually, let's see, we could do 2 times 8, which would be 16, plus 7 is 23, plus 1 is 24. Those aren't exhaustive. There may be others that I didn't get. So an exponent tells us how many times to multiply a base by itself. If we're looking at this, we have x to the n, where both x and n represent numbers. X is our base. And n is our exponent. So this is telling you how many times to multiply the base by itself. If you have 3 squared, or 3 to the second power, that's saying multiply 3 by itself 2 times, and you'd get that. 6 squared, or 6 to the second power, is 6 times 6, which is 36. If we had 4 cubed, so the 3 up there, 4 to the third power, that means you multiply 4 by itself 3 times, and you would get 64. So the exponent just tells you how many times to multiply its base by that number. We can represent an exponent with squares. So if you think about area models, an area model just helps you to figure out visually what's happening. So if we had 2 squared, we could represent that with this model here. The length is 2, the width is 2, so 2 times 2 equals 4. 1, 2, 3, 4. If we had 1, 2, what would this square, rough square, represent? Well, you've got a 4 by 4, so 4 by 4 represents 4 squared. Rewrite the number with no exponent, so that's kind of what we started out with earlier. If we had 3 squared, that would equal 9. 5 to the third is 5 times 5 times 5, which is 125. 2 to the fourth, 2 times 2 times 2 times 2, 16. Sometimes they'll give you this type of problem. You'll have 3 times 3 times 3. You'll have 3 to what power? So what you're looking for here is how many times are you multiplying a number by itself. So the answer here would just be 3. If we had 6 times 6 times 6 times 6 times 6, we count how many times are you multiplying 6 by itself. Do 1, 2, 3, 4, 5. So it'd be 6 to the fifth. So your answer here would be 5. Then the last type of problem you'll see on this homework is they'll give you a statement. You want to write it as an exponent, a multiplication problem, and then as a whole number. So it'll be something like 4 multiply, or 4 as a factor 3 times. So the exponent here, our base is 4 to the power of 3, so it'd be 4 cubed. This equals 4 times 4 times 4, and that would then equal 64. So that would be your whole answer. Don't put any spaces in it. This is the exponent, is this first part here. The multiplication problem is the middle part, and then the whole number is the end. One thing to be aware of on formative, so we haven't had to use the fancy type yet, but there's going to be on there a way to do exponents. Usually it looks something like this, or maybe a big box with a little box. But when you're doing your exponent up top, once you type it in, let's say you put in a 2, you're going to want to press the over arrow, the right arrow, to get out of this spot here and get it back into the big number there. If you're getting a wrong answer and you think it's right, it's probably because there's like a weird space up here, or if you delete your exponent but then get it back down to the main line, that's going to mess things up. So don't hesitate to just say, like, hey, I think this is right, and I can help you figure out what's going on if it is right. And then just a quick review of kind of how we're going through the class right now. As I've said before, once we kind of hit a point where it's new material, it's not as much review material, we'll change this up.